Hey everybody, welcome to West Coast Chasers. Today is Monday, January 6, 2024, and today I'm going to be discussing tomorrow's expected Southern California windstorm that is going to be taking place through the early morning hours of Tuesday, peaking around Tuesday night, Wednesday morning, going in through Wednesday. Now, currently, this is our satellite water vapor view of the continental United States. Here we have California, Southern California, Los Angeles area, and here in this dry air is what it's signifying. Here we have what is being shown as a shortwave trough. Now, to understand everything I'm about to discuss, shortwave troughs are basically our big weather makers in the United States. Troughs are basically these U-shaped rivers of air in the upper atmosphere. And this U shape is important because basically what this does is that you basically get two areas in this trough. You get the entrance region and the exit region. The exit region is promoting divergence in the upper atmosphere, which is indicated here. Divergence in the upper atmosphere, which promotes rising air. Meanwhile, in the entrance region of the trough, the left part of the U, basically saying this is a U. The left part of the U is the entrance. Right part of the U is the exit, and the left part you get convergence, which is indicative of sinking air. So sinking air in the front, rising air in the exit. Now, that's being indicated, like I said, this dry air here in Northern California right now. And if we go to our current mesoscale analysis, you can see here it is. Here's our trough. And following this black line, so you can see this U shape right here. And if we cut it in half, right here is the backside. There's the entrance reason. There's the reason of sinking air. And basically here we're seeing that these numbers are the knots, the wind speeds. And here we're getting 70 knot winds in the upper atmosphere at 500 millibars, which is around 18,000 feet. And here is Los Angeles. Now, right now it's Monday night. So over the next few hours, this strong air, if we go up even further into the atmosphere, up to 300 millibars, you can see here we have 100 knots. Here's 100. Here we have 100 knot winds in Northern California. And in the next few hours, they're going to be making their way to Southern California. Now, that's like, you might say, oh, that's up in the atmosphere. Why does that matter? That's like thousands of feet up into the atmosphere. And how does that translate into winds into the surface? Well, like I said, this is the backside of the trough. This is the area of sinking air. So this high wind speeds are going to be sinking to the surface. Here, here's a representation of that, where the green colors is the rising air, the pink colors is the sinking air, and you can tell that that's happening like that because here is the trough, and this blue line. So here's the trough, and if you cut it in half, that's how you get the entrance and exit region. So this is for currently about right now. That's what it looks like with the sinking air in Northern California, as it's shown here with the strongest air over there. So if you go to where the expected peak is going to be of this storm, Windstorm, which is about Tuesday night, you can see by that time the pink colors are very well in Southern California, which Los Angeles is right here. So sinking air. Another way that's represented is by something called cold air advection. So if we go to our upper air maps and we go to 850 temperature advection, you can see up in Northern California, it's blue. That's indicating cold air advection. That means that this area is getting colder and that sinking air is more dense. Cold air is more dense because cold air sinks, warm air rises. So cold air is denser. So uh that's creating temperature differences, right? If cold air is entering an area that's typically not cold, then that's cold air advection. And that's what this is indicating. Cold air is entering this area. And since cold air is denser, cold air sinks, that cold air is being transported down from in the atmosphere to the surface. And that's creating temperature differences. And once you get temperature differences, that's how you get pressure differences. And all wind is pressure differences. Wind moves, wind directions move when is wind direction is winds moving from high pressure to low pressure. So if we go back to our sinking and raising air, you can see here in Southern California we're going to be in sinking air, pink, and somewhere like Arizona, for example, is going to be in green, rising air. So it might be a little bit confusing, but to explain is that if air is rising here, that means that the air in the surface is moving to the upper atmosphere, meaning that the pressure is dropping here because air is rising. So because there can't be a vacuum, it's basically acting like a vacuum. The air is rising. So if there's air is rising, then there's less pressure. So aka lower pressure. So there's a low pressure forming here in Arizona, meaning so that means if air is sinking here in in California, that means that there's higher pressure. So the higher pressure is going to be somewhere. You can see that the highest pressure is here, like in Nevada, for example. So that means, relatively speaking, this winds are going to be going from this high pressure in Nevada towards Southern California. So if we look at a forecast model, you can see right now, currently, um, the winds are mostly in Northern California. The upper level winds are in Northern California, indicated by this, which is what it's showing. Here we have 100 knot winds in Northern California. So as time moves on, here's Southern California, right here. Let me make it yellow here. This is currently around right now, around 8-ish Monday night. So as time moves on, you can see here is 4 p.m. Tuesday. You can see now this that was originally up here. You can see it moved from up here and sinking and sinking and sinking. 4 p.m. Tuesday. Now we have that 120 knot winds at several thousand feet in the air. Like I said, that we're getting cold air advection. So this is 24 hours into the future. You can see Southern California is right here, and we're getting 120 knot winds in the upper atmosphere. But because we're in the backside of this trough, we're in the sinking air part. So if we go to our temperature advection, here, 850 temperature advection, it is also blue, meaning that air here it is even more blue. We can zoom in here to the region. Here's Southern California. And here we're getting very cold air advection, sinking air. Temperature difference equals different pressure gradients, meaning stronger wind. So that's why wind towards the right at Tuesday evening, when that 120 knot winds are right on top of Los Angeles, is why we're expecting it to peak around that time. Here's midnight Wednesday, or aka 11 p.m. Tuesday. Here we're getting forecasted 60 knot wind gusts across Southern California. The mountains of Southern California, you see there's a high pressure system somewhere in Nevada. We're taking wind through the mountains of Southern California, which is going to re-enhance it even further, creating the Santa Ana winds. Um, in November 2011, we also had a similar event occur. It's called the Pasadena Windstorm. And you can see this is the damage it did to a gas station. And we actually have weather maps from that day. So basically everything I just said right now about that, this 120 knot wind gust, way above in the atmosphere at 300 millibars, and that cold air advection, which were the two ingredients that are going to be coming together tomorrow. If we go to November 2011, here's 300 millibars, and here's Los Angeles, somewhere around here, and it's the same thing. These like light bluish colors, these are 100 knot winds right above Los Angeles. So that's one check mark. You have 100 knot winds going above Los Angeles at 300 millibars. And if we go to our temperature advection, you see it's blue. It's a very blue. That's cold air advection. That's sinking air. So that wind at 300 millibars is sinking down. It's obviously losing some energy. It's not going to be 120 at the surface, but it's that 120 knot wind gust at 300 millibars is sinking down to the surface of the earth, coming down from you see in this case, and from 2011, winds are coming from the southeast, from Nevada, going down to Southern California, and that's exactly what's happening tomorrow too. So it's getting reinforced by the mountains of California, and they're funneling through, and they're becoming even stronger. So that's why that happened in 2011, and now that's why it's happening today too. Even the Los Angeles, Weather Center is even saying something like, "What does it say?" It said it either earlier that it said something like, "Oh, this is going to be like the most significant event since the 2011 storm here." He's strong and damaging winds with dangerous fire conditions. Okay, that's the second part that I'm not even adding yet. I haven't mentioned yet. But strong and dangerous damaging winds for portions of Ventura and Los Angeles counties Tuesday through Thursday. Surface pressure gradients. Yeah, pressure gradients from the temperature changes. Upper level wind and thermal support. So upper level winds, that's the 120 knot winds above Los Angeles, and the thermal support, that's the cold air advection. Oh, here it is. Similar to the 2011 Pasadena wind event. Areas from around Simi Valley to Claremont could see gusts of 80 to 100 miles per hour. Wind gusts of 80 to 100 miles per hour will be possible across the mountains of Ventura and Los Angeles County. By Wednesday night, Thursday, the offshore winds will diminish. We check the NAM. Let's zoom in a little bit closer. Wind gusts. You can see somewhere around. Okay, so this is 1 a.m. on Tuesday. Somewhere around 4 a.m. We're already getting the strong wind gusts in the mountains, and they're just going to be getting stronger and stronger, peaking somewhere around. Even look, this is Wednesday, 7 a.m. Wind gust 40 miles per hour in downtown Los Angeles, 50 miles per hour in downtown Los Angeles, and but then they come back down, and we do get another round Thursday, but this is more in line with other Santa Ana wind events. What makes this one so abnormal is the wind going down into the greater Los Angeles area, which is usually not what happens. Usually it's confined to the mountains and valleys, but it reaching the Los Angeles basin isn't that common. So around Thursday, temperature 300 millibar, you see here. Yeah, look. So Thursday, 12. Yeah, at 12, we're already getting some of this energy already coming. But of course, it's like I said, it's peaking around here. Here's 10 p.m. Wednesday. We have 130 knot winds at 300 millibars. Which, if you want to take 300 millibars, is somewhere around 9 kilometers onto the surface of the Earth. But because that cold air advection is sinking those wind speeds down to the surface and bringing cold air in, making temperature differences, making pressure gradients, making more wind. And Thursday, so yeah, this thing comes a little bit that way. But then Thursday, we have a little bit of this more energy, but it's not as strong. Here it's 80 knot, and it's a little bit more to the Arizona area. And Arizona doesn't mean that that's going to be headed for, look here, Arizona. Here they're having 40 wind gusts, and probably they don't have the geography or something else that's gonna create wind gusts like we do. So yeah, that's it for this forecast. You can see here's the most important information from the Los Angeles Weather Office. Let's see this in full view. Extreme risk, like, oh wait, I forgot to mention the fire risk, right? So because it's bringing air from the desert, you can see here is around the time it's going to be peaking. So this is wind coming from, like I said, the southeast, so the deserts. So this is going to be lowering the humidity in the air. This is bringing dry air from the deserts. So if we check our humidity at the surface, here's relative humidity. Right now it's at 17, or right now it's at like 37. Uh, this is the most recent. I think it is. Or I'll just use dew points. That's a little bit better. Here right now, for example, tonight the dew point in Los Angeles is 46. Dew point is just like a way to measure the moisture at the surface. And here we have in Los Angeles a dew point of 44 at around 4 p.m. Tuesday. That wind coming from the desert, look at these dew points in the 30s and 20s in the desert. Well, that's going to be coming here. Here's 4 p.m. Wednesday with a dew point of 22. So that's low humidity. So low humidity plus strong winds means that any spark in any like cigarette thrown or any campfire or whatever, that's going to has a potential to spark a major wildfire, which is why the biggest area of concern is life threatening. Besides this damaging windstorm, is also going to be the extreme fire risk. Here, extreme fire. Low humidities will likely cause fires to start rapidly, grow in size with extreme fire behavior. So yeah, we're in extreme risk. You see here these pink colors. That's our which one's our fire risk, fire weather watch. All of this. So yeah, here's our hazards. So yeah, here's Los Angeles. Here we have a high wind warning. We have a red flag warning. Air quality. But we're also in a red flag warning. Particularly dangerous situation. Red flag warning in effect from noon Tuesday. Strong damaging north winds, low humidities will be a concern for wildfires. So yeah, that's all the information I have for tomorrow's expected wind event. So everybody take care. You know, the recommended things are, stay indoors and away from windows, expect power outages. These areas are most susceptible. This whole area right here from, Pasadena, Burbank, San Fernando, Hollywood, Beverly Hills. These are all the areas that are going to be, you can see here's our mountains. Here we have the mountains. So these are just going to be funneling through this wind and creating our area of greatest concern. So yeah, watch out everybody. Take care. Have a good night.